Hello. So today we want to talk about three different types of relays. We have a contactor, which you have all seen. We have a indoor fan relay. I'll explain that. And I've got another style relay, fan relay, or multi-purpose relay actually. So this is actually a double pole, double throw. So it has two sets of normally open, two sets of normally closed contacts. And it also has a 24-volt coil, which changes states on these contacts. So let's start over here with a double pole, double throw fan relay. So if we're to put L1 on terminal 1, then where we would see L1 is on terminal 2, because right now at rest it's normally closed. Terminal 3 would have no voltage because it is normally open. Now, if we were to energize this coil, then these states would change. They would completely reverse. So what we would have is L1 would now appear on terminal 3, whereas terminal 2 would have 0 voltage. And the same thing happens below here. So when we energize this coil, both terminals 1 and 4, whatever input they have will end up on terminals 3 and 6. Whereas if we have no energy at all on the coil, then whatever we put on terminals 1 and 4, we will see on terminals 2 and 5. Okay, I've got a little light bulb set up over here on the bench that should help. Now, here's a normally what we call an indoor fan relay. So what this has is it has one set of normally open contacts, and it has one set of normally closed contacts. So between terminals 2 and 4, it's open. Between terminals 5 and 6, it's closed. And terminals 1 and 3 are where we take our thermostat inputs from. So in this particular case, normally we would hook the green wire up to terminal 1, the common to terminal 3. So when the fan switch is turned to the on position, or the thermostat is turned to the cool, then it will turn on closed terminals 2 and 4. So now whatever voltage is present on terminal 2 will also be present on 4. Whatever was present on terminal 5 is no longer present on terminal 6. And last but not least, this contactor is basically a two-pole device that pulls in both contacts at once. So in other words, this is good for L1, L2 if we have a 220, 230 volt motor that we want to turn on, a compressor, anything that we would like to simultaneously energize two contacts. So as you can see, this has two separate contacts, and when this coil gets energized, and as you can see, somebody may have put a higher voltage than what is rated on. So what we have here is we have a typical 24-volt coil, and this contactor is outside in the condenser. So when we have a call for cool, what happens is the yellow wire gets energized through the thermostat, puts 24 volts on the coil, and the contactor immediately closes. So what would happen is, as soon as the coil energizes, these two would immediately close. So the load side, which we normally call T1 and T2, would be energized with whatever the line voltage is. In this case, we're using L1 and neutral because I'm going to use light bulbs to show you how this works. All right, folks, let's go over to the bench. All right, we're back again. So what I've done is I've set this up so it's ready to go. So what I'm triggering this off of is I'm using just the fan switch. So as you can see, I've got a contactor here, and the output of the contactor is these two light bulbs, neither one of which are on. This fan relay has two sets of leads coming off of it. So between terminals 5 and 6, we have the normally closed, and this light bulb is lit. And between terminals 1 and 2, we have this light bulb that's lit. Now, what will happen is when I energize, I'm using the green wire on the contactor, and basically what will happen is it will change states. These two, which are off now, will turn on. All right, so we had this, ouch, that light bulb and that light bulb lit. Now we have these two lit. These two were not lit. So let's try that again. Make sure my arm's out of the way. So now the states have changed again, and they have changed back to the on position. Okay, so this is simple relay logic here, so I'm just controlling light bulbs with it, but we can do much more sophisticated things with it. We can control more devices, and also notice that there's some symmetry to the wiring. It's fairly neat, it's fairly organized. We can tell that this is low voltage because it is smaller gauge wire. We can tell that this is the current carrying wire because it has a greater AWG. All right, and last but not least, let's talk about the wiring. So what I've done here is I've done this fairly neatly for you so that you can see that this is the low voltage wiring. Goes up here to the terminal strip that comes off the thermostat. And you can also see that we have sufficient gauge wire, AWG. So that's American wire gauge, okay? So basically here we have a 18, this is a 16, and this is a 14 gauge. All right. Thank you, folks. See you soon.